Continuing about new derivatives from old. We want to now show that derivative of sum of functions is sum of the derivatives. That is the sum rule. If f and g are two functions, both differentiable, then the derivative of f plus g is derivative of f plus derivative of g. What this means is, if I have an expression which involves two things, I want to take plus or minus, whatever, derivative of, all you need to do is find derivative of each function and add them up later. Now the sum rule can be extended to the sum of any number of functions. For instance, f plus g plus h prime is, you can split it as f plus g plus h prime. So derivative of the first plus derivative of the second. Now the first can be further split. In other words, because of associativity of addition, derivative can split through any number of pluses. Likewise, if I have f minus g, then I can think of it as f plus minus 1 times g. Now you use the sum rule to split the derivative. So derivative of a difference is derivative of the first plus my derivative of minus 1 times the second. Now you see, minus 1 is a constant, so it can come out. So essentially you are saying derivative of fx minus gx is derivative of fx minus derivative of gx. Constant multiple rule, the sum rule, difference rule can be combined with the power rule to differentiate any polynomial. Here is an example. That's a polynomial. Find the derivative. What did we just say? If we have plus or minuses, you can simply split along the pluses and minuses and find the derivative of each piece. What happens here? Now we are going to use the power rule. 8 comes down, power decreases by 1. 12, notice the 12 comes out because it's constant, and now you are going to take derivative of this. 5 comes down and power decreases by 1. Minus 4, where did this minus 4 come from? That's the amount multiplying this. So the constant comes out, derivative of x to the 4. 4 comes down and power decreases by 1, and so on. The last one, look at that. Derivative of constant is a 0. Derivative of function x is simply 1. So all that is here. So you found the derivative of a polynomial. Now what about derivative of product of two functions? If you have two functions f and g, you want to multiply them. If fx is x, gx is x squared, then derivative of f is 1. Derivative of g is 2x. So what about f times g? F times g is x times x squared, x cubed. So derivative of f times g is derivative of x cubed, 3x squared. All right. So notice, I don't see derivative. I cannot just multiply the derivatives of each. 1 times 2x would be just 2x, whereas derivative of the product is something entirely different from 2x. So make sure that we don't take derivative of product by simply taking derivative of each. That's not okay. That's an important warning. So here is the product rule. It is discovered by Leibniz and is called the product rule or Leibniz rule. Okay, both are acceptable terminology. Product rule or Leibniz rule. F and g are both differentiable. Then derivative of f times g is, well, you would take derivative of each piece, bring f out, derivative of g, plus g out, derivative of f. You can write that first, second, it doesn't matter. Derivative of one piece, keep the other outside. Derivative of the other piece, keep the other piece, first piece outside, so on. Product rule says that derivative of a product of two functions is the first function times derivative of the second plus second function times derivative of the first. In other words, you are going through derivative of each piece, keeping the other outside. All right. For example, if fx is 6x to the third, 7x to the fourth. So this is a product of two functions. Take derivative of each piece. So what are they doing? First, they are keeping the first one outside, taking the derivative of the second. Then plus, they are keeping the second one outside and taking the derivative of the first. All right. This gives me 4 comes down, 7 times 4, 28, x cubed. This 3 times 6, 18, x squared. Now you have all of this to multiply and eventually add. All right. What about quotient rule? Quotient rule is a bit more complicated, but the notion is same. Denominator squared. First step, square the denominator. Numerator is take the derivative of the top first, denominator as it is, minus numerator as it is, derivative of the denominator. So this is an important thing. There is a minus. You are dividing. So steps again, square the denominator as it is. What happens to the numerator is keep the downstairs up as it is, derivative of the top, denominator as it is, minus numerator as it is, derivative of the bottom. That's how you remember it. Okay. Derivative of this rational function. So square the denominator right away. Okay. Derivative of the top, denominator as it is, minus numerator as it is, derivative of the bottom. Now it's straightforward. You are taking derivative of this 2x plus 1 plus 0. Okay, denominator as it is, minus numerator as it is, derivative of the bottom 3x squared plus 0. Okay, now simplify. Remember, there is a subtraction, so keep the second piece at least in parentheses. They have simply multiplied it out, subtract another multiplication, you get a result. All right. Don't use a quotient rule every time you see a quotient. That's an important thing. Some quotient rule is quite complicated. So if you can rewrite your expression, do so. For example, here you could use quotient rule if you wanted, but it is much easier to divide. You see, the division is distributive. So you can simply divide this here, right? 3x squared over x. 3x. 2x to the half over x. So power half, power 1, overall power negative half. Now you can use, this is polynomial, you can use power rule here. All right. So general power functions, will come to that in our next slide, next video. Okay, until then.